Okay, good afternoon. Dr. Jensen here. Today we're going to look at a few practice problems dealing with significant figures as well as some basic unit conversion. Right? When we start off with the basics for things like significant figures, we generally have two kinds of problems. They generally are not focused about very complex chemistry problems. Usually they are just simple math problems. So here I have 1.54 times 0.03060 times 0.69. So this is an easy problem of just plugging this into your calculator to get the actual number. But the real question is, when you do this, your calculator, especially if you use a scientific calculator, you're going to get a whole bunch of different digits. And so the question is really, how many of those digits are really important? All right. So when we're multiplying and dividing, it is based on the number of significant figures. So we have to be able to know what digits are significant. Okay. So in this first one, I have 3 significant figures in the 1.54. In this one here, leading zeros are not significant. Okay. So the only ones that are significant here are these 4. Okay, those 4 are significant. Over here, again, the trailing zeros are not significant, so there's only 2 sig figs. All right, so when you multiply and divide, the answer is driven by which one has the fewest number of significant figures. All right, so when we do this, let's see, we get, so when you multiply this out, it becomes 0.033, right? And so you could leave it here as the 0.33 or 0.33 because again, these numbers here are not significant, right? Or you could do, right, we could do scientific notation where we move the decimal place over. So again, here you'll see that the zeros disappear. So if we change the scientific notation and they disappear, it indicates that they weren't significant, right? So the second problem here is addition and subtraction. So in addition and subtraction, it's not based on the number of significant figures, it's based on the number of decimal places. So the answer has the same as the fewest number of decimal places, right? So the fewest decimal places indicates the least accurate term. Okay, so just like in the previous problem, if it has less significant figures, that means it's less accurate. So the answer is driven by the least accurate measurement. Okay, so here, 1 decimal place, 2 decimal places, and 3 decimal places. Right, and so the least accurate term drives my answer. And so when I add these all up, so we get 73.0. So my answer has the same number of decimal places as my least accurate term. Okay. Now sometimes we have this in a little bit more complicated scenario where we have both multiplication and division and addition and subtraction. So in this mixed operation, again, we follow our same basic math principles of order of operation. So here, everything within the parentheses is going to go first. And so we're going to apply our significant figures to the first operation as we do it. All right, so as we do this, you're going to get, we have 3 sig figs, right? And 6 sig figs. Right, so my answer here, when I multiply these two together, we'll have 3 significant figures. And in this case, it comes out as 58.7. Right, is how that would work. Right, so this now reestablishes my baseline for my next order of operation. 1 decimal place and 2 decimal places, which means my answer will therefore have 1 decimal place as the least accurate term. And so I get 391.3 as my 1 decimal place answer. Okay. So here, when you do an operation, we want to apply our significant figures rule to that operation, and then do the next operation, apply the significant figure rule to that operation. Okay. All right, so let's look at another problem here that deals with unit conversion. So we have 808 meters cubed, right? And we want to know how many liters is that, okay? So we generally, if we don't have a direct conversion of meters to liters, we can go through some intermediate steps, right? So I know that in one centimeter cubed is 1 milliliter. And then I know that there are 1,000 milliliters in 1 liter, right? So I can go from meters cubed to centimeters cubed, right? And so that's kind of my order of operation that I'm going to end up going in, right? So I'm going to do 808 meters cubed, right? So when we work with cubic units, we already generally would probably have memorized the metric system units. So in 1 meter, there are 100 centimeters. Now this is a linear unit, but if I take length, width, and height, and all the metrics are the same for the metric system, we just cube the whole conversion. Okay, that's cubing everything in here. 1 centimeter cubed, therefore, will be 1 milliliter. And then there's 1,000 milliliters in 1 liter. Okay. And when we multiply all the numbers on the top, divide by all the numbers on the bottom, we will get 8.08 times 10 to the 5th liters. Key thing here, people forget, is we set this up right, but then we forget to cube, actually do the cube value of the number. So don't forget to cube the 100, okay? We wrote it here, so just don't forget to do that operation. Maybe write that number out above it, okay? And we multiply everything on the top, divide by everything on the bottom, okay? So this works whether we're doing square units or cube units, okay? Once you know the linear conversion just gets cubed or squared as we convert from the linear to the square or cube units, okay? So you don't have to learn one set of units, right? But again, this would be something you would have to have memorized. Again, same thing, you would have to have some of this memorized as far as our general conversion units. Okay, and that is it for this practice problem video, and we'll be back with more later.